Okay, 12.3 has to do with two-way tables and probability. Now, two-way tables are just a fancy way of talking about tables that have columns and rows. They're pretty straightforward. You've probably seen data organized in two-way tables before if you've ever used Excel. If not, it'll come fairly quickly. So go ahead, and if you haven't already, you need to make sure you've printed off the notes, because the next thing that's coming up is 5 questions, A, B, C, D, E, all from warm-up number 1, and you put your answers in right here on the page. So go ahead and make sure you have those notes in front of you, work on warm-up number 1, and put your answers in on the page. All right, let's have a refresher on probability before we start our warm-up here. Warm-up number 2, that is. So the first thing we have to remember is that probability is the number of desirable results or favorable outcomes over the total number of outcomes. We talked about this last semester when we started probability. So let's look at an example here to see how this all works. We can express probability in 3 different ways, either as a percentage, so something like, oh, it's 25% chance it's going to rain today, or as a decimal. So the decimal will always be the same as the percentage, only shifting the decimal place. So 25% chance to rain would be 0.25. And as a fraction, so 25%, so that's 25 out of 100, which would be 1/4. So all of those are different ways to express probability. Let's look at this example. So the probability of rolling a 1 or a 2 when you roll a 6-sided die. Pretty straightforward. What are the number of favorable outcomes? Well, you could either get a 1 or you could get a 2. So that's 2 different good things that could happen. How many total outcomes? Well, there are 6 different things you could roll, so the probability then is 2 over 6, which we could simplify and express in these different ways. 2 over 6 becomes 1/3, or as a decimal, 0.33, or if you convert that decimal to a percent, 33%. Okay, now there's 5 more questions. They should look very similar to the questions above, and you just have to go ahead and answer these questions now, talking about probability. Make sure that you look at the different answer choices to realize whether you're supposed to be using percentages, decimals, or fractions in your work. All right, let's jump right into our notes. Now, probability has a lot of different definitions, a lot of different terms, and they're very confusing at first. They don't make a lot of sense on their own, but once you start seeing how to apply them, they make a lot more sense. So stick with me through these terms right here, and then we'll jump right into how to apply things. So the first thing is a two-way table. What is a two-way table? Well, we've got an example of one over here. We've got this data arranged in the table. That's all of that stuff, those numbers. And then we've got some different categories. So the two-way table is a method to display data with 2 categories, and we get 1 category in the rows and 1 category for the columns. So in this case, if I look at what's my category for my rows, well, that's the different classes, so freshmen and sophomores. Or also what's my category for my columns? I'm talking about attendance, whether someone is attending or not attending. Let's say, for instance, this was talking about a dance. So I surveyed freshmen and sophomores to figure out whether they're attending or not attending a dance. So there's how I could display that data. Now, next word, joint frequency. So joint frequency literally just refers to the numbers in the table. So it's each individual entry in the table. So for instance, this 25 right here that I'm circling, that says that there's 25 freshmen who are attending. So that's how we can use those 2 categories. This one tells me about the class, that it's 25 freshmen. This tells me they are attending. All right, let's move on. Marginal frequency. Now, marginal frequency is a little bit different. So joint frequency is just the numbers in the table. They tell us about our responses, how many we had of each type. Marginal frequency is where we add together the rows or the columns. So for instance, right here, if I wanted to figure out total how many people are attending, I would look through here. I got 25 freshmen attending, 80 sophomores attending, so total I would have 105 biggest 5 I've ever drawn right there. If I wanted to figure out, let's say, the total number of freshmen who responded, I'd go this way in my table. I'd look, I have 25 freshmen who said they're attending, 44 who said they're not attending, so total I'd have 69 freshmen who responded to this survey. So these are marginal frequencies. So just two things to keep separate here: joint frequencies, individual things in the table; marginal frequencies, when we add together the rows or the columns. All right, example 1. So example 1 says, in another survey similar to the one above, we've got 106 juniors, 114 seniors responded. 42 juniors, 77 seniors are attending this dance. Let's put our results into a two-way table and then find and interpret the marginal frequencies. All right, so I've got some steps laid out. What I would recommend is putting your steps down the left of the space you have and drawing your table over in the right-hand side. You're going to see multiple tables here. You can probably make yours all on one. Color coding is a good thing for your notes. Use some colors. All right, so step 1, determine the two categories of data. This should be not too hard because this example is very similar to the last one. So we surveyed what? Juniors and seniors, and some of them planned on attending. I'm guessing the other ones planned on not attending. So our categories can still be the same here. We can still have class, in this case juniors and seniors, and we can still have attendance, attending or not attending. So then we are going to use that to do step 2, which is draw the table and add the titles in for our columns and rows. Just a reminder, since it's a video, obviously you are free to pause things, jump back to things, re-watch things if you didn't get them the first time, or pause things if you need to write stuff down and I'm moving too fast for you. All right, so we draw our table. We left this spot here in the middle. These are where we're going to put all of our joint frequencies, all of our data. And then I labeled my columns with attendance and put one column for attending, one column for not attending. I labeled my rows as class, put one row for juniors, one row for seniors. So this is the basic setup of a two-way table. Got some titles along the top from one category. We've got some titles along the side from a different category here. All right, what's next? Next, we're going on to the next slide. Okay, continuing this example, now we got to calculate the joint frequencies and fill in the table. Remember, joint frequencies is just a fancy word for saying the numbers in the two-way table. So there's my two-way table. You should already have that down. Now, from our given information, we should be able to fill in a few of these. So look at the words on your paper in example 1. It says 42 juniors and 77 seniors plan on attending. So that 42 and that 77 is going to go somewhere in this table. So it's 47 juniors planning on attending, 77 seniors planning on attending. So I put them in the junior attending goes the 42. In the senior attending goes the 77. But we're still missing some parts of the table. How am I going to figure out how many people are not planning to attend? Well, I have in my information that there's 106 total juniors. And so I can do 106 minus the number that are attending, 42, and that gives me 64, the number who are not attending. I can do a similar thing with my given information to figure out how many seniors are not attending. All right, we've got our two-way table filled in. Now we need to find and interpret the marginal frequencies. So the marginal frequencies are the sums of the rows and the columns. So we're going to create new columns and rows for these totals. So you can add this right onto your existing table. So we need to make a row along the bottom for totals and a row along the side for totals. And then what we do is we just go ahead and in each of these we calculate the totals. So I need to know the total number attending. I need to know the total number not attending. I need to know the total number of juniors. I need to know the total number of seniors. And I can get these by adding the entries in the corresponding row or column. So let's go ahead and get those in. Those ones are actually very easy, the juniors and the seniors. I don't even have to add them. I can get them right from my given information. For the other two, let's go ahead and add them up. I get 119 people attending, 101 people not attending. Now here's a really cool thing. We've got one last box. If I add these two, my total attending and not attending, I get 230. Let's add, or 220, just kidding. Don't know how to add 220. Now, if I add these two, my total juniors and total seniors, I get 220. This should work out every single time, that this final total, basically the total of the totals, should work out to be the same no matter whether you do it from the column or the row. So let's go ahead and add that in there, 220. Okay, now the final step is to interpret our results. So we're going to add a lot of interpretations here to our table. So first of all, let's talk about this 106. What's this 106 mean? Well, that means that 106 juniors responded to our survey. What about this 114? This 114 means we had 114 seniors respond. Now, what about this 220? Where does this 220 come in? How would you explain this number? You'd have to say that that's the total number of people that we surveyed, and so on and so forth. So here we'll get that the 101 is the number of students not attending, and the 119 is the number of students who are attending. And these two numbers, the 101 and 119, notice it's regardless of class. So it's 101 total students not attending from this survey. Okay, so the you try one there on your paper, on the same page where you put this example, that's for you to now go ahead and see if you can do the same thing. We will go over those in class. I will check those in class. So the next thing that we're going to do together is go on to the next section of notes. You can pause now and you do the you try, or you can keep going with the notes and then go back and do the you try at the end. It's up to you. All right, next section of notes. We've got some similar words, but they've got a slight difference. So now we've got joint relative frequency instead of before where we just had the joint frequency, joint relative frequency. So what this is the ratio of a joint frequency. Remember, joint frequency is just a number in the table to the total number. So ratio means fraction, it means divide. So I'm taking a number in the table and dividing it by that total number, the big total, the total. This really just gives us like the probability of a given outcome, the probability of a given spot in the table happening. And once again, like I said before, definitions, terms here, go ahead, stick with me as we do this, and they will make more sense when we apply them in an example. So next note here, marginal relative frequency. So we've talked about marginal frequency. Marginal frequency was when we added up the rows or the columns to get a total for a row or column. So this is similar. We just take the marginal frequency and divide it by the total number. So instead of taking the number in one of the just boxes in the table, we're taking one of the totals and dividing it by the big total. So I'm taking either the row total or the column total and dividing it by the big total. So this can also be found by just adding together the joint relative frequencies. We'll see that in the example. So once again, what we think here is this is just probability for a given row or column. So instead of putting the total number of seniors who responded or the total number of people who said they were attending, this is giving us the probability that someone was a senior or the probability that they're attending. Now finally, one new thing, conditional relative frequency. So it's just a combination of the two things above. So what it is doing, it's a ratio. Remember, like I said, ratio is a fraction. It is division. Ratio of the joint relative frequency. Joint relative frequency, that's the first thing in these notes, to the marginal relative frequency, the second thing in these notes. So basically, what this does, let's talk back in terms of example one. It's saying, what's the probability that if I know somebody's a junior, what's the probability they said they would attend? So it's like a conditional probability. It's not just saying what's the probability somebody said they'd attend, saying what's the probability that if I already know they're a junior, they're going to attend, or something along those lines. It'll make more sense as we do some examples. So also this can be found by dividing a joint frequency by its marginal frequency. And finally, we need to think that this is a probability of an outcome given a row or a column. So like given, we know we're picking from the juniors, what's the probability that they're going to attend? All right, pause now if you need to get the rest of these notes down. All right, example 2 now. So using the survey results from example 1, so we're using the same numbers from example 1. Now we're going to make a two-way table that shows joint and marginal relative frequencies. So in example 1, we made a table that showed joint frequencies. Those were the numbers in the table, and then the marginal frequencies. That was when we added the row and the column for the totals. Now we're going to be showing the same sort of setup, the same looking table. Instead of putting in just the exact numbers from the survey, we're going to be putting in the relative frequencies, which basically means we're going to be putting in a couple different probabilities for each of the spots in the table. So let's see what that looks like. We start with the same table, so you're going to need to draw the same sort of looking table right here. Now, to do the joint relative frequencies, what do we got to do? We've got to take the number in that spot in the table and divide it by the total number. So we're going to have to look back at example 1, so make sure you've got your example 1 there in front of you, and we're going to take the numbers in these 4 spots in the table and divide them by that total number of people who responded to the survey. So in each case, we're taking the number that was already there and we're dividing it by 220. And so that's going to give me some decimal here. This decimal will be a probability. This is the probabilities for each of those spots in the table. Okay, that's the joint relative frequencies. Now let's look at the marginal relative frequencies. Remember, the joint frequencies are the stuff in the table. Marginal frequencies are going to have to do with the total column or the total row. So I'm going to have to add on that row for the total below and also to the side. To do this, I can divide the number in the cell by the total number, or I can add the joint relative frequency. So let's look at that real quick. Here I've got these. So 2 different ways to do this. So I'll go with the easier one first. So add the joint relative frequencies. All I have to do is add these 2 together. This 0.191 for juniors attending, the 0.35 for seniors attending, and I get the 0.541 for the total attending. Once again, think of these as percentages so that, to make sense of what they mean. Another way to do this is I can take the number that was in this cell. Let's find a new color to show this. Let's use green. Divide the number in the cell by the total number. So another way to do this, the number in this cell was 121, I believe. So 121 divided by 220 should give me this number as well. So those are 2 different ways to get the same thing, and we could do either one of those in each of the spots on this table where I have purple in there, and that gets me the marginal relative frequencies. One last thing to point out, notice this right here, the total here is always going to be 1. When you're talking about probability, 1 means 100%. It's 1 out of 1. So this total will be the total probability of, somebody took your survey, they gave you an answer 100% of the time here. There's not a spot for people who weren't part of the survey, so it has to add up to 1. If it doesn't add up to 1, that means something went wrong. Okay, so now interpreting these, this 0.291 here means that 29.1, remember, if you want to convert from a decimal to a percent, you move the decimal place right to, so this means 29.1% of the students in the survey who are juniors and not attending. So 29.1% of the total students are juniors who are not attending. Let's interpret one of these marginal relative frequencies. So this means 51.8% of the students in the survey are seniors. So making a table, a two-way table like this with the relative frequencies can help if you have to answer a question about the percentages instead of just about the total number. All right, let's move on now. Example 3, conditional relative frequencies. So we're going to use the survey results in example 1 to make a new two-way table that shows the conditional relative frequencies based on the row totals. I'm going to just go ahead and underline that right now because it's kind of important. Based on the row totals. So let's start with this. How do we find the conditional relative frequencies? And I put rows again because it says based on the row totals. What does this mean? So basically what it's asking is us to find is some more probabilities, because it's relative frequencies again. Relative frequencies, they're all probabilities. So it wants us to find the probability, let's say, of this box right here, not out of the total, but out of the row total, whatever row total was over here that I just put an X on. So we're going to be using the numbers again from our original table, but we're going to now be figuring out the probability someone attended out of the total number of juniors. Or the probability, let's say a different one, that someone did not attend out of the total number of seniors, not out of the total anymore. So how do we do that? Divide the individual probabilities by the row probabilities from example 2. Awesome. So we have to look at what we have in example 2, and we're going to divide the individual probabilities. Those were the ones that were in the cells in the table, the joint relative frequencies, and we're going to divide them by the row probabilities. Those were the ones that were the totals for each row. So this first row, I took each of the numbers that were already in the table, the individual probabilities, and I divided them by the 0.482 because the 0.482 was over here as the row probability. And then similarly for the second row, I go ahead and take the numbers that were in that row, but now I'm dividing it by the 0.518 because that was the row probability for seniors, or the percentage of seniors there in the survey. So let's talk about what this means now. So this means right here, this means given that a student is a senior. So since we're doing this with the row totals, we're doing given that the student is a senior. That's where this 0.158 came from. We're only going out of the percentage of seniors. Given that a student is a senior, the conditional relative frequency, or just the probability that he or she is not attending the concert, is 32.4%. So notice this number right here and this number, the 32.4 and the 67.6, if I made them percentages, together they add up to 100%. That makes sense because if I interpret these, this one says given a student's a senior, what's the chance they attend the concert? And this one over here will say given the student is a senior, what's the chance they do attend the concert? So together they should add up to 100% because the seniors either got to attend or not attend. All right, let's go on. One last thing to do. Oh, once again, the next section, the U-Try 1, 2, and 3. Well, it's titled U-Try number 2, but it has 3 parts, 1, 2, and 3. That's for you to do now to follow what we did in these 2 examples, and then I will check that in class. So the next thing you're going to see here is example 4. All right, example 4, finding conditional probabilities. So this is a lot like what you just did in the U-Try and a lot like what we did in example 2 and 3. So we're already given a two-way table here that has joint relative frequencies. So the joint relative frequencies, remember, this is just like putting percentages in each spot instead of just putting the total. So this 0.29 here, 0.29 for Glendale, yes, means that 29% of the respondees fell into this category. And this is 0.03 here, means that 3% of the people who responded to the survey fell into this category. So, question A, what is the probability that a randomly selected customer who is located in Glendale will recommend the provider? So this is conditional probability because there is a condition on the situation. So the condition on this situation is like the restriction. So it's probability, randomly selected customer. We want to know if they're going to recommend the provider. But what's the restriction? The restriction is that the customer has to be located in Glendale. So when you're doing one of these conditional probability questions, you have to find the restriction first. And we're going to go ahead and actually restate the question now that we found the restriction. So given that the customer is in Glendale, so we put the restriction first. We state the restriction right out. Given that we know our customer is in Glendale, what is the probability that he or she will recommend the provider? So let's look at our table right now, and if you are going to mark things out like I am, make sure you do it in pencil because you'll need this table later. We only care about customers who are in Glendale and what's going on with them. So this stuff right here is not really part of what we're doing. We just care if a customer is in Glendale, what's the chance they're going to recommend this provider? Yes, no, 75% of the time, 90% of the time. Let's see. So what we do is we're going to be using that, what was that word? It was we're going to be calculating the conditional relative frequency. So it's written like this. P stands for probability and then parentheses P of, so it's like f of x when you see something like this, f parentheses x. This doesn't mean f times x, this means f of x. So same thing, P of, and this says yes given Glendale. So this bar right here means given. So there's a probability that they will respond yes, given that they are in Glendale. So let's see how we calculate that. We take, the bar is actually nice because it's kind of like a fraction. So we take the probability of people who, or the percentage of people who said yes and were in Glendale. So that's 0.29. And we divide by, see the bar right there, the Glendale comes after the bar, so it comes on the bottom. We divide by all of the people here in Glendale, all of the probabilities added together. So 0.29% of them, or 29% said yes, 5% said no. So I put those added together on the bottom. And then all I have to do is simplify that. If I simplify, I get 0.859 when I type it into my calculator. So what does that tell me? That tells me that the probability a customer who is located in Glendale will recommend the provider is about 85.3%. All right, let's do another example so we can get another look into how exactly this works. So part B, probability that a randomly selected customer who will not recommend the provider is located in Long Beach. So let's find the restriction first. So once again, probability of randomly selected customer. What restricts the customers who will not recommend the provider? So we're picking only from our customers who will not recommend the provider. So that means I can get rid of all of these customers up here. This part of the table is not important for this problem. So let's restate it. Given the customer will not recommend the provider, well, what's the probability that this person lives in Long Beach? So I'm going to rewrite that in my probability notation. So P of the probability of Long Beach, person living in Long Beach, given no. No meaning they don't recommend the provider. So remember this right here, Long Beach given no. This is like the fraction we need to set up. We need to use our table to get that fraction. Oops, erased way too much there. Let's get rid of that still. So I need to take what I have here, the probability of someone saying no in Long Beach, 0.04, and divide it by all of the no's added together. So that's my fraction, 0.04 divided by all of those no's added together, 0.05, 0.03, 0.04. Then I just simplify this, and when I type that into my calculator, I get 0.333. Repeating actually, but I'm just going to round for now. So if I want to make my conclusion based off this, I can say the probability that a customer who will not recommend the provider is located in Long Beach is about 33.3%. All right, then there's one more for you to try to follow up with this. And once again, with that you try, I will go ahead and check that in class.